Hey, hi guys. Good evening.
Hi, Ankit. Good evening.
Did you guys practice the discussion that we had yesterday around drag? Have you had any doubts? Did you get the chance to go through the code around that, maybe?
No, I didn't get chance. Actually, yesterday I didn't attend the class, so I go through, this yesterday recording.
Uh-huh.
I'll do that.
Okay, that's important discussion that we had yesterday. Please go through
Yes,
that.
yes, I saw that.
Yeah, we discussed around
And
how we are building the RAG application,
I have
different
given,
parts of it.
idea to my
Mm-hmm.
company. Okay, so if they approved it, so I'll start working on one application, Gen AI based application in the insurance.
No, that's great.
Yeah. So it's in just yesterday I have day before yesterday I gave them complete use case study.
Mm-hmm.
If they found that use case study and the application, what kind of application would be developed to
Mm-hmm.
fulfill that requirement or solve the problem which faced by the insurance companies. So if they
Mm-hmm.
approved on that, then it might be funded to work on the Gen AI based application. It is it will use RAG, LAN chain, uh,
Mm-hmm.
multimodal, and agentic AI to work
Yeah.
on.
Okay, so in that case, what we discussed yesterday, what we are going to discuss today, and I would say all the discussion that we had, all of them would be useful for you to
Yes.
build any use case around Gen AI.
So that application would be around to basically depend on the RAG model. It's
Mm-hmm.
extensively RAG model.
Yeah,
So
that
there
would
are
be fun.
multiple documents. Need to read it. That doing embedding, you know, on the
Mm-hmm.
yesterday lecture, what you told us how to, the RAG model actually work on it, and we can
Mm-hmm.
use it, making a center, a different cent clustering into, chunking into that based on
Mm-hmm.
that application is going to work on it.
Yeah, that would be fun, I'm sure. Okay. Uh, Hi all to the new folks who just joined.
Yes, sir.
Did you guys had chance to go through the code and everything that we discussed yesterday? If you have any problem, yes, Ashok, please continue.
No, sir, I just said hi. Hi, sir.
Yeah, hi. And please call me by my name. Uh, I think that would be much better if that is okay with you.
Yeah, fine with me. Fine with me.
Yeah, great. Okay, so I think we can get started. We are already 5 minutes into the session. We will get started with our today's agenda, and we'll be building over and above what we have discussed yesterday. What we have discussed yesterday can be broken down into multiple smaller pieces that we have discussed yesterday. And today, what we are going to discuss, we can put all of this together into one single entity, right? Any one of you have heard these terms called Lang graph till now? If you guys are new to LangChain, then I think this Lang graph would also be a new term for you guys because Lang graph is built over and above LangChain only. It's a high level framework which uses LangChain underneath and gives you the flexibility to make your sophisticated code base, your complex code that you can build in your whole pipeline. It gives you that flexibility that your code is modular. You can add at any point of time, you can remove something at any point of time. It modularizes your code and gives you better flexibility, scalability in your code. Uh, and I'm sure you must have heard of agents, no?
Agents we heard actually, agents.
Yeah. What do you understand when you hear this term agents? What is your understanding of it?
The agents is something is like automated, right? So it's more
Mm-hmm.
of we can say we have that proactive, reactive, right? To
Mm-hmm.
yeah, something like is by
Yeah.
default it's automation which will
Uh-huh.
take care of everything. It's
Mm-hmm.
agent, something like that.
Yes. Yeah, correct. You are on the right track. Anyone else wants to add? Uh, okay, I'll take it up then. Uh, so agents are something that can work autonomously. They have decision-making capability and they are goal-oriented. You assign a task, you build an agent for that specific kind of task, and the agent will use all its tools, all its logics that you have built in that particular agent, and it will work towards that achieving that goal to successfully complete the task that you have given to that particular agent, right? It can have tools, it can have multiple tools, it may have only one single tool, it may not have any tool. It may be LLM enabled, it may not be LLM enabled, it may have your complex code inside, sitting inside. So LLM is, sorry, agent is not necessarily something that you can refer to as LLM. Agent can have multiple things other than LLM as well, right? So that is a agent. It has a goal. It has something task to finish, and it works on the architecture or the internals that you have decided, you have framed when you were building this agent. Agents have the term has become more popular with the large language model has come into picture. We are automating some of the tasks like chatbot we are building, customer support agents we are building some agents which can automatically handle some of your tasks, right? And these agents can be quite complicated. Today we are going to see some of those scenarios, right? But when we are building the agent, Langfuse is something that is going to help us to build any agent, because if your agent is simple, straightforward, one single LLM call, you are taking, you're doing something. But by default, these LLMs are not enabled to take any sort of actions, right? Your LLM can just generate something. It can take a decision, but it cannot actually act on something. Let's say you have an agent which enables you to, let's say you are making an API call, and with that API call, you are updating your database or you are fetching something from your database. So your LLM can write that query, your LLM can give that command, but to actually execute that command, you need certain tools, right? That is what my tool is. We'll be discussing the tools in details in today's session. We'll be having a good discussion around what LangGraph is, how to build a graph, how to build that modular code, how to pass different arguments between those different nodes. We will be discussing these terminologies like node, edges, conditional edges, what is my entry point, and most important, what is my state, because state is very important thing in here, right? We'll be discussing some of the agent like React agent. We'll discuss that in detail as well. And integrating my Langfuse, how can I stream the status inside my agent or from inside my graph, so that I can make my whole tool much more interactive, much more, you know, uh, not only it is not only that when the whole operation is completed, then only you respond to the user. In between, you can stream some of the things. What is streaming? Also, we will be seeing that what is streaming. And then we'll be also looking at stable diffusion model. How many of you have heard of this term stable diffusion? It is a text to image generation model. Till now, all the models that we have discussed, all the models that we have seen, we have worked with, they were all text model. But stable diffusion, and similarly, there are other models which are primarily built or which are primarily trained towards generating an image out of the input text. Whatever the input text you provide, they are tuned internally, their parameters, weights, and everything is adjusted so that they produce an image. Their image can be of different quality. Sometimes the image can be very rubbish, sometimes image can be very good as well, depending upon the how good the model is tuned. Exactly the same way we have earlier models which were very like not so good at generating text, but models that are launched recently, they are very good at instruction following, they are very good at tool calling, they are very good at different kind of tasks. Like some of them are very good at coding tasks, some of them are very good at generating some of the content like creative content, advertisement or creative writing and all that part, right? So similarly, this is again a different type of large language model which produce the image output, different quality of image as well. Sometimes it's 480 cross 480, sometimes you can put it 1024 cross 1024, depending upon what the model you are choosing, right? We'll be also looking one of those model which I have tried to run on my local machine, and my machine was literally trying to produce that one image itself. But I have tried that so that we can take a look at that together. Okay. Any doubts in here so that we can get started with the agenda of today? Okay, I'll take the silence as no. Maybe to get started, maybe you can put in the chat how you guys are feeling today, so that I can know that you guys are there and you guys are listening me, and I'm not talking to myself. Are you guys excited with today's session? Do you think this is something which can help you build the use case, any of the use case? Okay, thank you guys. Yeah. Okay. Also, by the end of the session today, I'll also want to hear some of the use cases that you guys want to try. Uh, some of the use cases around drag, maybe explore some more field, like you want to use some structured data. We have not discussed structured data yet. Structured data means tabular, where you have a CSV file or a table which goes in the input. We have not yet discussed it, but it's not much different from how we are handling it today. Just the approach changes a little bit, but you can definitely give it a shot and you can give it a try, right? I would want to hear some of the interesting use cases before we close the session today, and it would be fun. We can see if we can incorporate any of those use case in our session, right? So let's get started with the today's session. So what is a lang graph? Lang graph, as I have briefly mentioned earlier, it's a framework that enables you to have added control on your workflow. And when I say workflow, I mean when your code starts executing from start to end to achieve a certain objective that you have in place at that particular point of time, in that particular point of time, what is the flexibility, or it gives you that control that at certain point of time what needs to be done, right? If you can see, there is this graph on the right hand side. This graph starts in here, there is something that comes in here, there is some sort of classifier that comes in place at first. Whatever the user query is there, we have a LLM based classifier in here, or it can be non-LLM based as well, depending upon whatever you want to have in here. You have a, let's say, LLM based classifier in here which classify the user question between different segments. One can be logical and one can be therapist, right? Then whatever this my large language model classify the user query into, my router will direct the flow of my execution in that direction. If my classifier says that this question was around therapist kind of scenario, it will route this toward my therapist. Or if it is towards my some logical scenario, it will direct towards my logical. So this is my router which will take care of it. Let's say I can add another the path in here as well, which is, let's say, some general queries that are available apart from these two other kind of queries, which will be handled by some miscellaneous kind of query, and they will be answered in here and you can go in here. So it's like this is your starting point for your graph. When your graph enters into execution mode, and then your path is decided based on different possible paths that you could have for that particular query in your scenario. And you would always want to have some fallback option. So let's say in this particular scenario, if your classifier classify the user question into something other than and it depends on your classifier also. If you have very good classifier that classify the user question into logical or therapist, perfectly fine. Let's say if you want to add some another scenario, and when I say it gives you that flexibility to modularize your code in this particular scenario, what do you think how difficult it would be for me to add one other path in here? How difficult it would be? I just need to have one more class here in my classifier, and I need to add tell my router that if that particular new class comes in, then you need to route it to a different help desk, right? So it is this easy to add something in your code, to reduce something from your code without impacting rest of your code architecture or your code pipeline. You just need to add these additional configuration to your particular pipeline in that particular scenario. So this lang graph, it gives you from the graph itself, you can understand this is a um, graph kind of architecture, which is a directed cyclic graph. How many of you have heard this term before, or how many of you are listening it for the first time?
I'm listening for first time.
Okay. Anybody else? Have you
Uh,
have anybody heard this term earlier?
no.
Already known. Okay. Chaitanya, maybe you would want to briefly discuss about DCG, directed cyclic graph.
Yeah. So in directed cyclic graph, just like this, there is a starting point and ending point.
Mm-hmm.
So in terms of this, if user want to like re-enhance their prompt, re-enhance their like whatever the LLM is produce the result, it's not
Mm-hmm.
satisfied with their result, then
Mm-hmm.
it move that cycle to the starting point and restart the whole process. This
Mm-hmm.
is something like cyclic. We are
Yeah.
moved to the first point again.
Mm-hmm. Yeah. So it's like it has a defined starting point, it has a defined end point. And let's say there was also a scenario where my router says that it needs to go to the logical agent, but my logical agent says that this is not something that I handle. Return this query. It can return it back to my router, and then my router can take another action. We'll see some another example where this back and forth goes on. Actually, this cycle operation goes on as well, right? We'll see some in our React agent itself today in our today's discussion only. So those are my directed cyclic graph, which has one direction of execution, which has some starting point, which has some end point as well, right? It's not that it will go in the loop infinite. Sometimes it can go in the loop infinitely, but then it comes to our recursion limit, how much we can bear that loop, right? If that goes beyond our limit, it will break, ending up saying that we could not generate the answer, right? But it is kind of your code will break at that limit. What is the limit that you can tolerate around with, right? So LangGraph is a agent AI agent framework which bring you added control of the agent's workflow. You can control the workflow at different point of time in this particular scenario. We have something called entry point. This is my start entry point, and this is my graph end point. When you are building this graph, we will be seeing in our today's code itself that when you are building, you need to define all this scenario. What is your entry point? Where you want your code to end? We'll be building this graph itself. And this facilitates the creation of complex, stateful, and multi-agent application using large language model. Complex, again, there can be, this is very straightforward, very simple graph that we have in here. In my organization, I have a graph, exactly similar kind of graph, which has more than 50 nodes. This individual function, let's say, this is called a node. And we have more than 50 nodes. We have more than 10 different routers, which can come into play at different, depending on different conditions. We have more than 30 variables which define what will go at what point of time, right? We will discuss in detail. So this application can go really complex, and LangGraph gives us that flexibility to have that orchestration on my complete pipeline, right? And when we come to our individual node, we will discuss this in our next slide itself. This individual node itself can be very minute function, like I can have some retrieval only the retrieval. This node will take a question in the input, like in my RAG application, it will take question in the input, and it will return back my results retrieved from my vector database. That's it. Simple. You can have one node which will do only this much of task. Internally, it has that small piece of code, or you can have your complete RAG application into one single node itself. Completely depends upon how you want to your whole architecture, how much control you want at different levels, right? That completely depends upon the scenario. And it is built over and above my lang chain. From the lang itself, you can make sense out of it that it is built over and above your lang chain, which gives you orchestration part, right? There is something called as graph state. We will discuss. Graph state is something that let's say you have a parallel line of execution that is going on, and it is acting as a shelf. And when I say shelf, let's say you start with a question, right? You put your question in here. Then you go to node one, or let's say function one. Your function will take question from here. It will do some processing and return something to this shelf only. Your second function will take something from here and will return something here only, right? So it's like your shelf that is available across your all your functions. You can use the information, you can accept or you can take any of the information that is available in your graph state. You can use it, you can process it, you can update it back in your state, right? And you can have only certain number of block, whatever you define at the starting. You can only have these many potential shelf or potential blocks in your shelf. These are called like variables. You can have only the variables in your shelf, which which you start in you start in the beginning of your architecture, right? You cannot have, let's say, you have something called as question, you have something called as answer. You have only two blocks in your shelf, which is question and answer, right? But let's say after first node, you call your retriever, and your retriever returns something which is, let's say, retrieved document, and you want to return it back to your state, but your state do not have that block to accept that retrieved state, right? It will not accept it. You won't be able to access it anywhere in your rest of your code, because you have not configured it, you have not configured your state, or you have not configured your shelf to accept that variable. You do not have a position, or you do not have a placeholder for that particular variable in your state, right? So that is my graph state that we saw in here, and this is very important when we are building the rest of our architecture access, right? Which is accessible across different nodes in the graph, right? This allows high-level control and abstraction of managing complex large language model applications, right? We just discussed that we'll be having multiple blocks in our shelf. We can have n number of nodes, n number of functions, n number of router. We can decide our path, and we can build the complete use case. Once we build our use case, we can put this complete use case in one part of your overall, let's say, a bigger problem. So it's like you are trying to solve a very big problem. Let's say you start with the problem statement that your chatbot will answer question from structural data, unstructured data, right? But you have to start somewhere. Let's say you start with structured data first, right? So you build an application, you build complete pipeline for structured, you build a complete graph basically for structured data, right? And then you want to add unstructured into this particular scenario, right? Either what you can do when the question comes in, you can then itself decide, you can put a classifier whether this question will go to my classifier, sorry, the unstructured data pipeline, or it will go to my structured data pipeline. Once you decide that, then you can have two separate graph in parallel as well, right? So it gives you that complete flexibility of how you want to orchestrate your flow of execution in the pipeline, and it also helps you debug it as well, right? It gives you scalability, it gives you flexibility, and it gives you efficiency when you are building a complex code, right? Any doubts in here in understanding what my lang graph is? We'll be seeing the use case of how we are building lang graph as well. I have pulled this code. Just give me a moment. I'll just get the slide in place.
Aniket, just before you move forward, I had a question. Like,
Mhm.
is agent is comes before the line graph is introduced, or it is agent is coming after the line graph is introduced?
No, agents were there already for a very long time. It's just that they had popularized with large language model. Earlier, those agents were very, rule-based kind of thing. That if input comes into something, we classify it based on my machine learning model or my other models that are available in place, and I there was some workflow that was being executed, right? That was not very intuitive, or that was very conventional way of doing things, right? Just like we saw in machine learning, that there was rule-based actions that were taken, right? Now with the large language model, those decision making has become very easier. You do not need to place rules everywhere. You'd let's say in case of classifier, for classifying a problem, whether it is a logical or whether it is a therapist kind of problem, earlier you need to have a good system in place to classify this. Now you have a large language model which will take this decision for you. And once you have the decision, then you can connect your tools, right, to take action based on whatever the decision was taken.
Okay, but there is in a lang chain there is a term routing,
Mhm.
and same thing is happening in the agent. So how routing is different from this
No.
agents?
So agents, we will see what agents do. Agent has some goal to take, some goal to achieve, right? It has some tools which enables the agent, or which enables the large language model to take some action. LLM itself cannot take action. Let's say you have integrated a chatbot with your WhatsApp, and whenever a user query comes in, it will respond to the user automatically, right? Or let's say based on the user query, it will try to understand the user query. Let's say you have a shipment that is available, or shipment chatbot, right? When a customer comes in and asks for the order status, the chatbot, if the order ID is not found in the user query, the chatbot will enable a pipeline which will trigger and which will ask the user to get the order ID. Once the user enters the order ID, it will route this question to another tool which will fetch the status of the shipment for my order ID, right? User can add, okay, this is my order ID. User can write the input, let's say, this is my order ID. It can have additional text also, right? Let's say user write, this is my, right? And it can place some, let's say, 10 digit alphanumeric kind of thing, right? So the task of my large language model is to first extract this particular order ID from the complete text that is given, right? Pass this ID to another tool, which was to extract the status. Like when was the order placed, what is the current status of the shipment, what is the tentative time of delivery or the date of delivery. It will extract all this information. Once the agent has all this information from the tool, it will pass this information to the user. Okay, this is something that you have asked, and this is the information that I hear. At the back end, what this can also do, it can also store this information, that okay, this user has asked for this inquiry and this was the action taken, right? It can log into your system as well, right? So this is routing. Your agent is deciding which tool to call at what point of time. This is the decision making that your large language model is doing. And need not necessarily always that your large language model is doing the decision making. You can enable certain flags based on your pipeline, to what pipeline to trigger or what route to take at what point of time. It's not necessarily always the large language model that will take the decisions. Does it
Okay.
make sense?
Yeah, like there at the previous thing, like
Mm-hmm.
initially when agent is not introduced,
Mm-hmm.
there is always there is routing is happening previously, but
Mm-hmm.
we did not give that name agent. But when we have this power, we call this as agents. Like why?
Okay,
Why?
so earlier, how was the routing happening?
Like what?
Mm-hmm. On
I'm
what
not.
basis we were routing the queries to different pipelines or different part of the pipeline? How we were deciding what route to take?
As you said previous, there can be a two ways to routing. Like via LLM, we make the decision via LLM, or we can set the flex.
Mm-hmm.
By this way, we can route the.
Mm-hmm.
We can do the routing.
Okay, so now when I say agent, I am not just referring to my router. Just understand this. I'm not just referring to my router. There are other things as well which combines in together in one single terms as agent. The agent can have large language model incorporated. It can have tools that are available, right? It can have like different decision what it can take, and the tools will enable this agent to take certain action to achieve a goal that comes in the input. Let's say your agent has five different tools. We'll be building one use case that I was planning when we will be working with model context protocol, where your agent will have tools like it will get the table names, it will get the table schema, it will build the query, it will execute the query, and it will get you the final answer. All this will be done at one single agent will do all this. It is not just the routing, it is the complete uh, pipeline that is executed using the agent. Agent will decide what to do at what point of time. You
Okay.
were earlier hard coding certain routing based on certain decision that were coming in. Now that which tool to call, which route to take is completely independent. You are not adding something. You are just tuning your agent to achieve the target, whatever the goal that you have given, whatever the task has been assigned, and the agent is smartly flowing through what action to take. Does this make sense?
Yeah.
Okay. Anyone else? Any doubts?
Might be, can we say in this way, sir, without agent, right? It's
Mm-hmm.
gender. We call it as Gen A, right? Which is a
Mm-hmm.
generative, based on your text. It will
Mm-hmm.
generate the data, and internally, router is something like in the agentic framework, but
Mm-hmm.
in Gen A, it will you decide that based on some of the parameters you tell the model to act on the question and then give the output. Can we
Mm-hmm.
say in that way? Because uh, if it is a Gen A, we have some classifiers and then some pipelines will be there, and you call some transformers on the
Mm-hmm.
data, and then while on the data, you tell take these parameters and then
Mm-hmm.
analyze my data and then give me the output, and you tune the parameters, and
Mm-hmm.
then you work till you get the best parameters, and then you decide then the data. So I think this is more of manually we do it in Gen A without
Mm-hmm.
agent.
Mm-hmm.
My understanding with your explanation with the Langgraph is that intelligence is built in Langgraph,
Mm-hmm.
where its agent will take those decisions
Mm-hmm.
and then it work accordingly. Can we say in
Yes.
this way?
Yes, sort of. Yes, you are right, right on track. One really good example that I would like to highlight in here is how many of you have used the OpenAI API key? You can use the same model, GPT-4o, 4o mini, all the models that are available through your API key. Have you guys tried? Okay, I'll tell
Yes.
what the difference is. Yes?
Yeah. I'll use.
Yeah. So do you see any difference when you use the model, same model through your API key and through your chat GPT UI? Do you see difference in the response of these two approaches?
Actually, I haven't tried on the same question.
Okay. So
But
on the
if
API
I
part, yeah.
if I say OpenAI is like agentic, right? That's is it my understanding correct?
Yes, this
Yeah,
chat GPT UI that you use through UI, you can just upload your PDF, start
that is
questioning.
Gen A. That is a Gen A, right? It doesn't have
Um,
agent built in inside.
yes,
You can say
that
that.
any
Yeah.
large language model inside is part of that Gen AI.
Okay.
Both of them has large language model incorporated, but
Okay.
this is your raw model directly available. Whatever it produce, it is available to you. But when this whole large language model is incorporated in certain scenario, it becomes a what we get on our UI. When you ask a question, it structure your response in a certain format, right? It doesn't
Right.
just, and there are other models which you call as thinking models, right? They are agents which are built in such a way that whenever a user question comes in, they analyze it, they rethink what they are producing, they question themselves, and then produce the answer. This is the internal architecture of how the agent can work, right? That agent can have multiple LLM sitting inside which are working together. It is not just the large language model, it is not just the decision making, but the whole thing in one single framework that we can call agent. In UI, you just upload your PDF and start asking question. Internally, it is automatically configured that whenever a user PDF is incorporated, you need to answer from this PDF. or the user must be asking something from this PDF that has been given, and it's automatically switch it accordingly, right? There are internally it is configured that whatever the PDF is added, we first need to extract the information from this PDF, then use this extra information that is given by the user in the PDF to answer the question, right? You are not adding anything additional in there. It is automatically doing it because there is an agent sitting inside which has all these capabilities that when a PDF is uploaded, it extract that content, it use this context to answer your question. So there is this kind of architecture internally. And this architecture can be straightforward, it can be complex. But underneath, they are both using similar models. You can use same model on both the side. Using API, you can use 4.0, 4.0 mini, O1, O3, O4, all the models that are available. On the UI also, you can use these models. But the difference is about how they are available to answer the question. At one place, you have not just the large language model, but other features incorporated along with your large language model, which is my agent. In total, it is called agent. Does this make sense?
Any example very straightforward agentic any because ChatGPT is Gen A example, right?
we
Any
will we
example?
will we will we will see, we will be building one of the use case. We'll build this use case only. We will see, and we will build one agent also today, that is called a React agent.
Any publicly available any agent public available?
All the chatbots that you see that are AI enabled, they are all agents only. All the chatbots on Amazon, you see there is this agent which suggests you something, or
Right.
any other agent, or any other interface that you are using with
Okay.
respect to any industry, any uh,
Bank and all right. Even HDFC Bank has some
everywhere.
bot. Okay.
Everywhere, if it is a LLM enabled, it is not always raw LLM that is available to you. There is backing of certain tools available for that large language model, which can help the large language model to answer the user question, right?
Okay. Okay.
Yeah. Any doubts in here? Okay, so we'll be discussing some of the terminology. I think most of them we have already discussed, but I'll reiterate. If you guys have any doubt, please feel free to stop me right then and there. We can discuss it because these terminologies are again important. Just like we have discussed the previous terminologies, these terminologies would be important for us to understand or build or build more complex architecture. These are the basic terminology that we'll be using back and forth here and there. More or less, these will be the terminology. There might be some additional, but these will be the basic terminologies that we'll come across. One is the state. State is one of, like we already discussed, it is a shelf that is available for you throughout your pipeline from start to end. This is what you have at all the functions that you have in your pipeline. It can have different placeholders. Let's say you have a placeholder for question, you have placeholder for retrieval, you have one placeholder, let's say you have some flag available, right? You define this state before you start building your graph or before you start adding things into your graph, right? Before you compile your graph, you define this state prior to that. And not only the name of those variable, you also define the data type of this variable. Let's say this question is going to be my string type. This flag can be, let's say, Boolean, right? Or let's say this retrieval thing can be my list, right? Or there can be another which can be of dictionary type, or there can be one which is of list of dictionary, right? You define all these parameters before you start working. Let's say you define something which is of string type, but you are trying to update with a list data type. It will end up throwing an error that it is not supported. You need to see what that error is. You need to update the data type, or you need to work around if that was an error while you are updating that state, right? We'll see how we update that, how I will see how we are retrieving the information from the state and how we are putting it back in my state. So this is like a shelf that is available to you at all places. We'll see how we do that. Graph, we just see this is combinations of nodes, edges, and conditional edges with defined entry point and an endpoint. This will be my graph. What a node is, we'll see now. What a edge is, we will see. What is the conditional edge, we will see. But these are different component of a graph, right? Uh, if you do not have these, I don't think you can build a graph without any of these components. You need to have a node, you need to have a connection between these nodes to build a pipeline or to build a graph architecture around this. What a node is? Node is an individual function. You can take it as a function which accepts some arguments, right? Which process some information, which can be LLM enabled, which may not be LLM enabled depending upon your use case. It can be your simple script that you can write inside it, or it can be LLM enabled, and it will return something back to your state. It will accept arguments from the state and it will return something back to your state, right? That is my node. Individual node is like an individual function. You can process your information. You can take some action inside this node and you can update something inside this node and return the updation back to your state, right? These, whatever you do at one node, let's say you have node 1, you did some processing, you updated the state in this node, and then you have node 2 available. Whatever the information that you have updated in here will be available for you to access in your node 2. So this states allows you to access those parameters without bothering about whether it will be available there or whether it will not be available there. That complex architecture is taken care of, right? So these are my nodes. What are my edges? If you have noticed in my previous image that we have seen, uh, let me go here. I'll just clear the screen. This is my node, right? Where I am some processing some information, taking something from my state, which is available to me as a shelf. It has a defined starting point. It has a defined ending point, right? And this is some node which is processing some information. And after this information is done, there is some connection that is there. This is called my edge, right? It is one directional. Always edge is going to be one directional. If you want to have this back direction, then you need to have another edge that will be a different edge altogether. It's not that you can have edge which is bidirectional. You need to create a separate edge which will connect router back to classifier, right? But it is edge is always one directional. From a router, let's say in this particular scenario, from a single node, you can have multiple edges outside, right? If it is a single edge, then it is a straightforward edge. But if you have multiple edges coming out, you are putting some condition on each edge, right? It is not just randomly assigned whatever it comes, whatever is available at this router, it will assign randomly. No, there is some logic in place, and you are putting that condition that whatever condition comes in, let's say you are updating a flag based on the flag status, you are routing whether it was a logical or whether it was a therapist kind of problem, right? Or you can also, let's say, without even having a router in here, from the classifier you can directly have a router in place without having this router node itself. Currently here I have added a router node, but need not necessarily that you have a router node. You can directly connect your router with your classifier, and based on that you can classify directly whether which path to take. And whenever a particular condition is met, the graph or your pipeline or that part of your pipeline will trigger based on the condition that is available there. And you have something called as end. Your graph has to end somewhere, right? It cannot just randomly go. Let's say you have a node in your graph which is not part of your graph. Is it possible to have a node which is not part of your graph? Yes, no.
Which will do some specific task. You're saying
Yeah, it will do something, but
some
let's say while you are building this graph, you missed certain node, or um, you gave the output to this node, but you don't know how to trigger this node or what the input of this node was. So whenever you are defining all these nodes, we will see how we define these nodes. you need to have, if you are defining a node or if you are adding a node to your graph, first we add all the nodes in your graph. You'll see that in the code. Let me just pull up the code, that will make more sense there. Yeah. So can you guys see the screen? Can you guys see the
Yes,
collab
yes,
code?
yes, yes, yes.
Yeah. So these are some of the library packages that we need when we are working with this. And this is where I'm defining my state. Currently, which is of my type dict class. Currently, I have only one variable in my state, which is messages. This is the name of my variable, right? And this is my type of this messages, which is a list type, and it is going to add messages, right? This is how I define my graph. I can have different, let's say, another variable which is question, and which can be of string type. I can have, let's say, another variable answer, which can be of string type or none also. You can pass it like this also, but generally you just do it like this. Whenever you are creating a variable in your state, you always need to define the data type of that particular variable. You cannot have, let's say, uh, you have like this and you pass it just like this. No, it will end up throwing an error. That you need to define the path, the data type of your whatever the variable that you are, or whatever the placeholder you are making in that particular pipeline, right? So you need to have that. And once you have it, you define this class state. You need not necessarily you give the name a state only. You can give whatever the name you want to, but you will need to define the data type. You need to define that uh, uh, name of this variable, and it should be like, because you will be using it later on, it should be sensible what you are giving the name of a variable, all that part, how you write your code. And then you need to pass it as your graph state. This is the import from your lang graph that you do, that your state graph, and you are passing this whatever your graph state would be. And then this is where you will build your agent. This is the first thing that you do whenever you are building an agent, that you create a state, right? And you pass it to your state graph, and you have your graph and you have starting of your graph, that your graph will have some state, right? Then what you do, you add a node to your graph. This is how you add a node to your graph. You define a function. Let's say this was my function, which takes the state. This is going to be for all the nodes, your input is going to be the state. That's it. One single argument, that is going to be your state. That's it. Whatever the variables you want to accept, whatever the variables you want to use from the state, you need to get those variables from the state itself. But you only need, just like here we did, we got the messages from my state, right? State is going to be a dictionary. You can get all these variables, all these placeholder from your state, and you can use them. In this particular scenario, what I'm doing, this function, what this function do, it takes the message, it does the LLM hit, and it get you the output. It gets you the response. That's it. Simple. What it is doing, it is taking the user input, making a LLM call, getting the output, returning it back. That's it. And this is updating the messages that I have got, and I am adding this as a node. You see this graph builder dot add node. Add node is a method which will add a node to your graph. You can add 5 node, 10 node, 50 node, 100 node, depending upon whatever the use case is. You can have n number of node in your graph, right? So this is how you add your nodes, right? Then you start with the edge, how you connect those nodes in your graph. Simply you have a add edge method, which will what is going to be a start point. Let's say in this particular scenario, your start is here, and you're connecting it with your chatbot, right? This start is again imported from your lang graph. This is your start that you have already imported in here, right? And you are going to define, this is how your graph is going to look like, that you started your graph. This starts in here. There is this node chatbot. Whatever the response is coming, it is ending here. That's it. Simple. Does this make sense? It is again simple LLM call, no tools enabled, nothing additional in here. It is just a LLM call. User input comes in, it makes LLM call, whatever output comes in goes out. That's it. Simplest graph that you can build, right? This is and if you want to see how your graph looks like, you can display it like in this particular format. Sometimes this draw mermaid is not available. You can draw different graph as well. You can explore it over the internet. But sometime we have, like I myself have observed that like till 5 minutes before I was able to print this graph, I was able to view this graph. But again, there was some error with respect to this draw mermaid PNG, and I'm not able to print this. There was some issue with this package itself. And then I need to explore different option of how I can view this graph, and they are available obviously. So you can do that as well, right? And in between, you also need to do this, that you need to actually compile. It's like earlier you were adding all these ingredients, you were adding the nodes, you were adding the edges, and then you need to compile all of it together so that it everything stitches together and it is available for you to use, right? Does this make sense? Yes, no?
Yeah.
Okay. And I have also tried to put them together so that we can try this. I think we will be doing the imports and it is going to take time. But I'll be sharing this notebook. I'll surely like appreciate if you guys give it a shot, because definitely this is worth giving it a try. So it's like whenever when I run this cell, it will accept a user input and it will take this LLM input. So if you see in here, this is how I invoke my graph. If I am streaming the input, this is how I'm invoking my graph, where I'm taking the user input. I'm putting this user input in my graph state. Here I am putting this in my graph state, and I am passing this information inside my graph. When I'm invoking my graph, I'm passing this information so that I can start my graph. Or it's basically a dictionary only, where the key is the messages, and I'm passing it in this format. Role is user and content is whatever the user input there. Do you remember this format? This kind of format? Okay. Is N8 an alternate to LangGraph, making it simpler to create nodes, edges? Okay. So N8N is something which is going to automate things for you. Yes, it is similar to what you are building here, but N8N is going to automate it for you. Here you are coding yourself. You are debugging yourself. You are going through the code. You are writing your code yourself. You will have more control in here. In N8N, you just need to drag and drop things for there, and you can just get started. There are other challenges to deal with there. Here are some other challenges to deal with, right? But more or less, they are trying to ease your life. If you like to code, go with this. If you do not like to code, then go with the platform like N8N, or there is also something called Langflow, which is similar to N8N only. Okay, yeah, great. So, how many of you just recognize this pattern of passing the information? This is from the prompt template that we have discussed yesterday. Yep, it is sort of JSON, but this is how we pass the information for large language model in our chat prompt template. I'm passing this information, and whenever so this is like I'm streaming. So when I said, remember yesterday when I not yesterday, just a little while before, when I said that we don't want our user to wait for the response, right? So what we do at every execution of after execution of every node, we update something to the user. We do not wait for the whole thing to get completed. So it's like after one node is completed, you extract that information. Okay, this till here it was done, and now this is the information updated, and you can pass it to the user if you want to, right?
Progressive
And
update. Progressive upgrade.
yeah, you can say progressive update, but let's say in sort of RAG application, you do not want to exactly show user what has happened, but let's say when the user question comes in, your first node is to retrieve the chat history first of all, right? So let's say you retrieve the chat history. On the user, you do not want to show that we are retrieving chat history. You can just simply say that we are retrieving the context of the conversation, right? Once that is done, you are going to use the user query to retrieve the information or retrieve the information from your vector database, right? Then you can say, okay, we are preparing your information. We are looking into the universe to get relevant information from the universe, or whatever you want to display it on the user side, right? you will have the update in here, like in this particular format when you do the graph stream. And for each event is like whatever the information was available at that point of time, right? What is pydentic? Am I correct? Have I got it right? Pydentic? It's kind of this JSON breakup of the information only. It's a data type that you can put in place, which is compatible with our LLM or AI based sort of application. Okay. So this is not necessarily you need to do this graph.stream, but you can also do graph.invoke, just like we were doing in our earlier session. In that case, you won't have the intermediate update. You will have just the starting and then the ending. You won't have any update in between. If you do graph.stream, this is where the graph is running actually, and whatever the events are updated, you can take those events and you can use it the way you want. If you want to display whatever the content was retrieved, you can display. You can update the user till where we have reached. You can club three nodes together and to update the user whatever the status of your progress is. That's completely up to how we design the flow of the complete pipeline, right? Yeah, and let's say just like we were trying to integrate our langfuse in our LLM calls, here also we can integrate the langfuse, which will gives us the observability. And remember earlier I mentioned that langfuse enables us to have good observability of our tool. Yesterday we were having just one LLM call, that's it, we were able to view that. But in this we will be able to see what was the input and what was the output. And let me run it through a little complex uh, graph so that we'll be actually able to view what has happened in there. Let me run it because otherwise we will not be able to see. How many of you are interested in seeing the langfuse at work? And this is the actual use of langfuse that we are going to today. Yesterday we saw that was a basic information that can go, but when you have a complex graph with 50 nodes, you want to see what is happening at each node. What was the input to the node? What was the output from that node? You want to have that visibility in your application. Langfuse will enable you to do that. Uh, where were we? Okay, let me run this. Okay, I need to. Okay, this is how my graph looks like. And let's say now you want to run some user query, right? So this is where it is going to answer your question, and I have like it is configured that if the user input is quit or exit and all that, it will end up. So this is just how it is displayed. It is just for the display, right? Ultimately, when it is running, it is going to call this function with the user input. That's it. And this is where the updates are happening. Does it make sense? Okay, let me add the langfuse. This is the same thing running in here. Okay, so this is, I would say, a little advanced version of the graph. Not so advanced, I would say it's just the basic one that we have seen earlier, which has multiple nodes this time, which will do just a bit minor complex task. And where first thing is that you have a user query and you will classify the user message based on whatever the sentiment of that was. Emotional was if the user asks for emotional support, therapy, deals with the feeling, or personal problems. Then you need to have some emotional agent that is available that can understand that emotional essence from the user query. Or if it is a logical problem like facts, information, logical analysis, or practical solution, some let's say mathematical kind of or some logical kind of scenario, then you need to have some logical agent in place. Now, then based on whatever the decision of your user query would be, I will be having a classifier or a router. Based on whatever the input type was, it will decide what is my next step. Whether my next step is a therapist, whether you want to go to a therapist or whether it should go for a logical. If my LLM classify the user question or the user input was something that you can classify into emotional, it will go to the emotional one, else it will go to the logical one. Inside your therapist agent, there is this prompt that is available that you need, you are a compassionate therapist, you need to do blah, 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 all this information that system prompt is available. This is again the uh, chat prompt template that we are passing in here, right? And you are passing this information back to your agent, right? And you are doing this llm.invoke and you are getting this reply and you are passing this information back to your user, right? And then you have similarly your logical agent, which will have similar kind of input architecture, which will respond based on the logical understanding of the problem statement, right? So till now, here we have all our backend configuration that needs to be done. Now we need to start working on building our graph. What my graph is, I have my state. My state has two variable this time. One is messages and the other one is messages type. Messages type, it can be again the similarly that we saw earlier, whether it was a logical or a therapist kind of thing, the classifier action that was there, right? So that is my state in here. I have built the graph. I have added these nodes. One is my classifier node, another one is router, then the therapy or a logical. These are my nodes. I define all the nodes that are there in my graph, that has to be there in my graph. And then I decide how these nodes will be connected. These edges or conditional edges will decide how these nodes will be connected together, right? I start my graph with the classifier. Now classifier is connected to a router. So what you do in here is you are giving the name of that node in here, or whatever you want to get displayed on the, let's say we are printing it, right? We are calling a certain node. What you want to call that node internally, it can have a number of things, right? So I'm putting a classifier in here. Internally, it is going to connect with the classify message function that you have internally available. You will call it as a classifier on the UI and everything. Wherever you are going to use this particular function next, you will call it with this name. Inside the graph, a particular function is called with this name, right? If you you can have the same function name as well as graph name of that particular node same. You can have that as always, but not necessarily. You may not. Just in this particular case, we have the function called classify message, but the name of that node is classifier. Does this make sense? Similarly, these all are nodes which can have different name depending upon, this is like my graph name and this is my function name. Simply, you can put it that way. And then you connect your graph nodes depending upon how you want to. So if you want to add a edge, you just do a classifier node is connected to your router node. And if you pass it directly as a add edge, you just pass the like a tuple, which is your first node connected to your second node, directly connected, no condition exists in between. But let's say you want to add a condition. That's how you add a conditional, as we have seen it earlier, where your first element is your which node you want to start this conditional edge with. Then you have some function in between, right? This is your function that will get the next step from your state. And whatever the next step is, it is like a dictionary. You can put it this way, that if your output of this particular previous, whatever the function that you have in place, if the output is therapist, you want to connect it with your therapist node. And if the output is logical, you want to connect it with your logical, right? This is how you configure it. So whatever the output from this particular rate, let's say your next was something which was not in therapist or logical. In that case, it will break because your graph will not know what to connect in which in this particular scenario. It is going to break. So you need to make sure whatever the state you are going to return from here, or whatever the value you are going to return from here, you need to have the same value, or you need to have the same entity get connected to a particular node. This is your information that is returned from your this particular function, this particular lambda function that I have in here. It may not be a lambda function. And this is the name of the node. The second one is the name of the node. Just in this case, these both were name of the node. Here, this router is the name of the node. Here, this therapist, logical, these are name of the node. But this first element is something that was returned, that was available from this function, right? You can put them same, no problem. You can put it different as well. That's completely up to you. And then you connect your therapist to what node you want to connect your therapist. You want to end after the therapist is done. You want to end after the logical is done. Or you can have a common node which will, let's say, save this somewhere in your database. Whatever the input was there, it will dump this information in your database and then end it, right? You can always have that. So till now, I have all the nodes, I have all the edges, I have all the conditional edges in place, and my graph is all done. But I need to compile my graph before I can actually use this graph. Till now, I was just like putting things all together. Now everything will be pasted, everything will be frozen once you compile it. If you have some broken edges, if you have some unknown node that is available, you will end up getting error at this particular stage because this is where you are actually compiling the graph, right? Once you compile the graph, you can directly use this particular graph for whatever the use case that you want to build in this particular scenario. So let's say if I want to run this, this is again I have put in this particular function where it will take the user input and it will just run in loop, right? So let's say if I place hi, it will return based on the LLM call. And this is again internally going just a LLM call. This time my LLM has certain information, certain path to take and all that information, right? I am feeling, let's say, sad. But in this particular scenario, do you think we have a observability of what is happening in here? What route it took internally? No, right? We are just seeing, okay, some input message was gone and some output has come. But internally, you want to see which agent was triggered in this particular scenario. You can always print inside in here. Let's say for each agent that is coming in, you can print, okay, this was a response from my logical agent, or this was the response from my therapist agent. You can print, but print is not, this is not how you can trace it once the application is in production or outside from your purview. If multiple users are using, your print statement is gone. You cannot log that information. You cannot trace that information correctly, right? So if I want to do that, that's where I need the Langfuse. That's where the Langfuse come into picture, right? And let's say, let's just break this at the moment and integrate my Langfuse in this and see how this is going to work. This is my graph. And let's say if I want to integrate my Langfuse in this. See, this is how my state is configured. And I'm passing this state when I'm going to ask the question in this particular scenario. And this is, I'm doing a graph.invoke. In this particular scenario, see, this is simple graph.invoke. I am not uh, uh, in between retrieving the status of what part of the pipeline has been done, what is still left. I don't want to show the user, right? This is just the input and just the output, nothing in between. That is happening in here. And to integrate my Langfuse, I need to have some config. Configurable, and then I passed my list of what was the variable name? Langfuse handler. Yep. How many of you observed? Is it same what we were, how we were integrating Langfuse earlier? Is it same or is it different? Is there any error? And trust me, you did not need to remember these syntax, semantics, and everything. You can always have look up on the internet if you are getting some sort of this kind of error. Slowly, you will automatically remember how things are happening, what the syntax semantics is, but you don't have to remember how you need to. But you just need to have this. Okay, if I need to add the Langfuse observability, I need to pass something in my config in here. I need to have some configurable parameters which will go in here like this, right? Let's say I want to run it. Everything remains the same in this code in here. It's just that I have added one more configurable, which is my config, which is for my Langfuse observability. Let's say, let's run it now. Okay, list item has Okay, it gave us an error with respect to config only. So let's take it from the earlier one itself. This is callback, not configurables. See, it automatically gave us an error and we were able to trace it. We got an answer. I gave this, and now I want to see which part of the pipeline was triggered. So let's jump to our lang fuse. Mm. This is where we are, 18.5, correct? At 2011. This is the input that we had at the moment. And the input was hey, and this is how internally, so internally the classifier went for the router went for therapist, and therapist gave us an answer. In this particular scenario, it was the therapist who gave the answer. Let me give you the second one, which was the bigger. This is the one. So this was the conversation happening internally, right? Internally, my lang graph, the input was initially it was this, then this was my AI response. I'm ready to assist you. Then my second question goes in. This is my I'm feeling sad. I had a bad day at work, which was not great. So this was the input to my agent. In this particular scenario, this has gone as input. You will see in here that this was the input, right? And you will see the output. What was the output from your agent? Your agent output was here. It sounds like you are carrying around a heavy emotional load right now. It was what is happening, right? But internally, I want to see what was the decision of my classifier. Just go to the classifier and see. Whatever the input has got, the output was message type was emotional. It was some sort of, this is what my classifier has done. Then what my router has done. My router has asked that this input emotional, then route it toward my therapist. And then my therapist came into picture. It took the question and it gave this output. So I can track what is happening at my individual node of the graph. What was input to my individual node, what was output to my individual node happening, right? And you can see this in this graph as well, right? So you can have this kind of observability when you are trying to debug. Let's say my router is not working properly, or let's say my classifier is not working properly. I can just take the input, whatever the input was going through my classifier. I can take this input, I can pass it through my classifier separately, the individual function separately, and I can see why it was failing, or I can improvise on that, right? So it can help. It helps me easy debugging of my complex pipeline, that it gives me this observability. Does it make sense? And internally also, let me put it a bit more deeper. Your therapist, this was your LLM call happening. For your therapist, this was the input message. This was your system prompt, and this was your input message. And this was your assistant output directly. Nothing here and there. It was as simple as that. This was your system message, this was your user input, and this was your output. Isn't it same as the one that we yesterday we were just seeing this part of it where we had the LLM call happening and the response coming in. Now we have different nodes integrated as well along with it. Does this make sense of how LangFuse is making it easier?
So how do we integrate this LangFuse when we have project? Is it separately to be done outside or?
No. So it's so this LangFuse is simply open source as well. You can host in on your own hardware, own architecture itself. You can have the uh, Kubernetes cluster. all right? Or you can have your own ports and everything running in your local machines, or you can use this cloud one that I am using at the moment. Cloud, they are also providing some of the free credits to start with, but then it becomes chargeable as soon as it scales up.
Okay, okay, okay.
Yeah. Similar to this, there is also another one called Langsmith. It is also doing the similar job. You can have the observability inside this only. Okay? Does this make sense? How many of you are going to try this particular use case? I'll be sharing this notebook. I would want you guys to do more practice, build different use cases with the Lang graph, come up with different use cases and try to build it. We can build it together. No? Does it sound interesting?
Yes,
Yes,
yes, yes, yes.
very
Yeah.
interesting.
Okay, we'll be having more fun. Okay. Shall we move further, or if we have any doubt, we can take it up right now? Yes, no, whatever your input is, maybe put it in the chat or speak up.
And this is only the framework we use for agentic AI, or we have some more other frameworks also.
We do have more, but this is the easiest one that I feel because I
Okay, okay.
love to code. There are other like Creo AI, AutoGen, which helps you similar kind of job you can do there as well. You can definitely explore AutoGen. You can explore Creo AI, which helps you build those agent faster.
And
Similar
Landgraph,
to this only.
is a Landgraph is a popular one in the market, or it's generally most of the people use for all the agentic AI, or
No, it depend on the use case. If someone's is finding Creo AI more handy, they can use that as well. Primarily, I would say in my organization, all of us loves to code. All of us loves to get all the control of what is happening inside, right? So we are building the whole code ourselves. We can use AI and everything in place, but we like this was the first one. To Langgraph was the first one that came in. Going further, AutoGen came in, Creo AI came in, but these are all additional framework that are helping you build. But I'll definitely suggest you to explore all of them because you might find the other one little more easier than this one. I personally find LangGraph much easier to work with. You can explore and you may find some other one more interesting. Yeah.
right? Okay.
Yeah.
And this is standalone code, right? How you're going to host it? Like, let's say you prepare a,
Mm-hmm.
let's call it a chatbot, right? You
Mm-hmm.
created a chatbot,
Mm-hmm.
and you want it for everyone to use it.
Mm-hmm.
How do you deploy it? How do you make it public? Because
Okay.
let's take I want this, whatever you develop this notebook, right, is a chatbot,
Mm-hmm.
and I want
Mm-hmm.
10 people to use the chatbot whenever they
Mm-hmm.
have some, right? How
Yeah.
do you do that actually?
Okay. So to build a POC, you want to show a demo to the client, maybe obviously
This is a
sharing this
POC
in a notebook.
standalone.
Huh.
This is
Yeah, it is
standalone.
standalone POC. You don't want to show the client's notebook, right? Where some red lines, red, blue, yellow code is written, right? You don't
Right, right.
want to show it to them. You want to have a simple basic UI that will work. You don't want a very fancy AI as well, well, UI as well. So what you can do, you can work around with Streamlit that will give you easy, faster, like very quick way of developing a basic UI. That is one. You can explore the other one called Gradio. It is also similar. I find Streamlit much easier for me myself. My Streamlit is go-to. I can handle different scenarios in Streamlit. I like Streamlit. Maybe you can explore both and come up with your doubts or whatever your findings are, whichever one you find interesting. And the good thing is, you can deploy these applications as well. Once you have your application on Streamlit, the one that I showed you earlier, you can host them directly on Streamlit directly, or you can host them on Hugging Face also. So if I show you on Hugging Face also, you have something called as MySpace. Is it somewhere here? Let's say I go to profile. Do you see these applications? These are some of the applications that I have hosted. These may be public, these may not be public. This is a simple application which you can host it. Or along with it, you can also host it directly on Streamlit server.
So Hugging Face is the repository. There's open repository for
Yes,
you. Okay.
there are all these repo, all these models and everything, and you can host your application, some simple basic applications there as well.
And how do you tell other people to access your bot?
You just share the link. It is as simple.
Oh, okay.
Yeah. Where do I log in? It was simpler earlier. Deploy it. See, you are getting deployed here. So for free, you need to log in with your GitHub and you need to deploy. These are some of the applications that I have already deployed. And they are also, if you are not using it for some time, they have to save the resources, they will put them into sleep mode. Whenever a user comes in, they will need to wake this up application.
Okay, okay.
That happens. Yeah. So these are the application that I have developed: web scraping from LinkedIn, translation web app, RAG custom chatbot, resume analysis, right? Dashboard automation I have done. These are all the basic use cases just to show as a demo that you can build around with, right? So there is one which you can have a chatbot for CSV analysis. You can upload your CSV files and you can start asking question directly, right? So these kind of basic simple application you can deploy it in here. You can share it with your clients. Obviously, if you want to have a dump of the chat history, what user is asking, you can also put a login page in here. So you can also have what particular user with what particular login you want to add in here. You can do that. If you want to store a history, maybe in that particular scenario, you want to have a particular node in here, which will store this history for the whatever the question has come in, right? So you can do that as well.
Okay.
Yeah. It's about how you integrate or how you prepare your use case. Putting it into code or putting it into as a demo for the user is not of a big challenge, at least for um, developers. Like we are building some use cases. Simply a Streamlit can work there. We don't want a very fancy UI. We just want something basic. I want just a button. If I click, some action happen. That's it. The
Okay.
color of the button and all that doesn't make much sense in our use case for now, at least.
Right.
Yeah.
Right. Yeah.
Yeah. Any doubts? Uh, Sorry. Yeah. Do we have any more doubts or we can proceed further?
Yeah, we can proceed. Yeah.
Okay. Okay, so we'll move to the next agenda for today, which is my agents, tools, right? Till now, we were building the lang graph. This lang graph enables me to build the agents, right? Which can have multiple tools. How many of you understand what a tool is? Based on our discussion till now, or maybe some of your understanding earlier. What is your understanding around tools?
A tool can be a specific application, right? For example, right, tool, I can say Grafana is a tool, right?
Mm-hmm.
So it comes with its own architecture.
Mm-hmm.
So
Yeah. So tool can be something where you are making some sort of API calls, maybe
right.
LLM itself, a third party integration you want to do, which enables the large language model to take some sort of action, right? By itself, large language model cannot take action. You need to give some additional power to the large language model so that they can use those tools to take some action, right? You want to have, let's say, a tool which is just like in our earlier scenario, you want to have this order number. The LLM will take the order number and it will call the tool, which will fetch the information of particular order for the client, right? It will get the status, whatever the tool will return. The agent will, or the large language model will process this information and display it to the user. So by itself, large language model was not capable of getting the exact information about that order number. But by enabling or by providing that tool to the large language model, you enabled the model to take certain action for that particular use case, correct? So that is my tool, which can be API enabled or a custom script also. Not necessarily always it's some sort of third party integration that you are going to do. You can have some custom script also that is happening inside. So let's say you have a tool which is just for calculation, right? It will take two number, three number, whatever the numbers that this tool is configured to do. It will do just the calculations. It will do, let's say, a multiplier. It will just multiply the two numbers and it will return the output. That is my simple basic tool, right? That can be also be there, right? That AI model interact with to retrieve information, perform computation, or complete specific tasks. These are at the disposable of the large language model. When to call, what to call, that is completely up to the large language model. It enables the large language model to take action. Tool should have proper definition. Now it comes how you create a tool. How will a model know what action can a particular tool can take? How will the model know that? Or what? How will the large language model know what is the argument that this tool needs to get the information or take that particular action, right? So let's say in a particular scenario of a calculator as a tool, you need to tell the large language model that okay, we have a tool called calculator and it can perform mathematical operation,
Great. Yeah. And
right?
actually,
You
you
need
can
to.
provide API, right? So
Hmm,
if you tell
yes.
LLM to call this API with the key,
uh,
it will pass the arguments and get the data.
Yes. So it's like you are defining what is the actual information or what is the definition of that tool. When you create a function, let's say ABC is the function and it takes some argument, right? And then you pass some information. This is your definition of your function that you pass in here, right? This will help the model to understand what exactly this tool will do. This definition has to be clear, has to be concise, has to be very precise for the model to understand what is this tool going to do. If you are messing up with the information the way you provide this definition, the model will again miss out on certain points and it may not work as expected. So this information has to be very clear, precise, and correct with respect to what this tool is going to do. Also, you need to define what is the input schema. You need to define what input it takes. What is the data type of this input, the input that you are going to pass in this particular tool, right? And you also need to tell what this is going to return, right? So there is something called as arguments, right? These arguments, let's say there was some argument which was question, which is of a string type, and this has some description. This is the user question. You also need to define these arguments as well. Just like the definition of your function, you need to also give a definition or a description of a particular argument that is going in this particular scenario, right? So you need to have that. If you are messing up with this information in here, that means your model do not correctly understand the functionality of your tool and it may miss on certain scenarios, correct? So this has to be very clear, precise. You need to give explanation about argument, return functionality of tool along with the data type. Data type is also very important because let's say your in this particular scenario, in case of calculator, it accepts the two number as a list, right? And it accepts this list and it will multiply all the elements in this list and it will return. This is what your calculator tool was doing in this particular scenario, right? And let's say your input that your LLM is sending, it is of string type and it is sending all those number 1 comma 3 comma 5 comma 25 comma this, it is passing it like this, not as a list but as a string. In that case, your model when the tool start functioning, it will expect a list but it is getting a string and it will break, right? So you need to handle all those scenarios that you're defining all these parameters when you're building or when you're creating this tool, right? Some tools like web search tool, this will take the, let's say, user question and it will surf the web and it will get the answer and it will return the response for this question by searching the web. You can have some calculation tool or you can have retrieval, like in our RAG application. You can build a tool which will retrieve information from your database for the user question. It will take the user question and it will retrieve the information and it will return back the information retrieved from your database. You can have that tool. That will be an independent tool, irrespective of what is going back and forth. This tool will be independent of what is happening around, right? This is my tool, independent tool. But when I integrate these tools with my large language model, now my large language model is actionable. It whenever you define a task, or whenever you give a task or a goal to your large language model, it has something to achieve, some task to perform, and it tries to use those tools to get that task completed. You define the prompt. The prompt in case of your agent becomes very important, whatever the prompt that you pass in here, right? You tell that all that tools that you have, you define the purpose of this agent, you define what is the input that the agent is going to receive, what it needs to do, how it needs to process that information, how it need to call that tools, and how it needs to get to the answer. What is the actual agenda or the task that you are assigning to this agent? You need to have that very clear, concise work. It can operate independently, making decision as in which tool to call at what point of time, and taking action without human intervention. This is the most important part, that it may not need a human intervention. It can independently work standalone to get to a particular task achieved, right? That it can do. AI-enabled system to pursue goal and complete specific task. It is goal oriented always, and it can be a sophisticated network of LLM enabled with certain tools. Tools is one of the important part in here. Like in case of our chat gpt, there must be chat gpt that you use on the UI. There must be a agent which have tools, like which is going to retrieve information from the PDF and give it pass it further to your large language model. There can be another agent which will, let's say, take the image. Whenever you paste the image in the UI, it will take the image, extract the information from that image, and use it further to as a context when you are answering the question. So there must be these different tools that are enabling the agent, or that are enabling your large language model to perform certain action when it is generating that response for the user question, right? So that is my agent. How we build an agent? Let's see how we build those agents. I have for that as well. We'll go to the React agent next, but let's just see how we build those tools, simple tools, how we are going to build those tools. Let me pull the notebook. Just give me a moment. One thing that I would suggest you all is to practice this, because this is the information that you are getting in right now in just 5-10 sessions. This is something that I have been working for years now, right? So you need to have like some time spent on this, gets your hand dirty, stuck in some problem, try to debug it, try to resolve it, take help from your peers. If not, try to search on internet how you can debug that particular scenario. Till the time you are not doing this, you are missing out on certain part of this whole problem or the whole use case that you can work around with. So please practice this as much as you can. If you are stuck somewhere, if you are not able to resolve it, please feel free to put up in the class discussions, and we will take it up for sure. Yeah. But yeah, let's see how we can build those tool, or how we can enable our large language model for tool calling. Tool call is something that has enabled my agents, or initially when the large language model came, like 3 years before now, the large language model, they were just producing the next tokens, right? They were not very efficient in following those instructions. They were not very efficient in taking actions, or when I say taking action, in deciding which action to take, right? They were not very efficient in tool calling, what we call as tool calling. But slowly the tool calling started. As soon as the tool calling, the functionality of tool calling was incorporated with large language model, our agents framework become more popular, because our agents need those tools, how to call those tools. That is the important part. So now we will see how we do this tool calling part of it, right? So this is simply in here we are going to see there is something called as Tevely search result. This is a web service that is available for you for free. I think you have 1,000 requests that you can do, and this is 1,000 as in you can get the API key for free to start with, right? and you have 1000 requests per month, you can scrape the web for a user query, whatever the user query or whatever the input you give to this API call. And this is completely, you are not doing anything. You have just one API. You are calling that API, you are passing some information, and it is doing some job internally, and it is returning you the processed information. This is a perfect example of a tool. We are not touching anything. We are just importing this Tavily. I am just configuring this my Tavily search result, and you can configure how many search results you want. You can configure what domain you want to search this result for, right? You don't need to do much in here. You just need to configure your Travely search result, and you can just have it in your tools. Currently, I have this variable called as tools, which holds this Tavely search tool for me at this moment, right? So once you have it, again, I'm just giving my chat prompt template, and I'm creating tool calling agent. This is a tool calling agent. I doubt this is something that you are going to use currently, because this was when we started with the tool calling thing, right? This is the agent that is available from a very long time now. And this is the building from where it started. So I thought this is going to be an important one, where you just need to pass your large language model, which is your large language model, which will take all these actions. You need to pass the list of all your tools, and then you need to pass your prompt, right? Your large language model can be your any large language model, whether it is OpenAI, whether it is your Llama, Mistral, right? Meta, like all those models that are available. It's just that it needs to be your large language model object from LangChain, right? Once you have that configured, you have your agent ready. It is simple to build your agent, which is going to do your calling your tools and everything. And this tool calling agent is available. I have just imported it from your LangChain agents. This is your pre-built agent, right? And you can just call this agent. And in this particular scenario, see, I have done this, executed it, and stored it for you guys. Where my input was, when did Virat Kohli retired from Test cricket? And this was like just a couple of weeks back, and it is not. I'm sure this is not available in the large language models knowledge bank that it had, or the on which it was trained, right? So we can actually see that it scraped the web. So it internally you can see. So there is something called as verbose. What verbose do? Whatever the thoughts are taking place inside that agent, the agent tried to call a tool. What was the information that it passed to call the tool, right? So it is invoking this tool. The tool name is Travely Search Result JSON, and it is passing this information where query is this Virat Kohli retirement test cricket date, right? It passed this information, passed this query. My query was something else. When did Virat Kohli retire from the cricket? But my agent or my large language model smartly modified my query to this particular statement to get the information from the internet. And whatever the information it has got, it is available at this link. This is your Travely search result. Travely search result gives you back that it also gives you the URL as well from where it is getting this information. And it gives you this information, and it ended up last with this particular information. And the output that I got was based on the search result. Virat Kohli announced the retirement from the Test cricket on May 12th, 2023, which is a incorrect information. It is not 2023, which is 2025, but it was able to retrieve this information from Facebook, from Times of India, right? But it is around how your now, if your output is incorrect, that means something wrong has happened with your tool. Your tool did not return correct answer, or if your tool result returned a correct answer, your LLM missed some information somewhere. That's why it is giving the final response as wrong. How you can debug it? Again, go to your LangFuse, see what was the input, to your Travely search result tool, what was the output from your tool, and if that tool information was used by your large language model, and what was the actual where it went actually wrong. You can trace it through your LangFuse. Does it make sense?
Yes, yeah.
Yeah. So this was my one tool. Currently here, this only my one tool was integrated in this list of. I can use my like multiple tools at the same time. Your agent will have, or the large language model will have the multiple tools at its disposal, and It will be smartly choosing based on the user query. So let's say in this particular scenario, I have this tool called weather, which is just returning this information. It is a weather, it is currently sunny in this and whatever the location that I'm passing. It is internally, it can do a API call, it can do some complex processing, whatever the script that you want to write, or it can do a combination of these two. Internally, it can have a large language model itself sitting inside a tool as well, right? It is completely independent of how we are consuming it. Your tool you can build independently. It's just that it needs to go in hand with how your large language model wants to use it, or the agent wants to use it, or the supervisor agent, the bigger agent wants to use your smaller workers, right? There is this your get weather tool. Currently, I have fixed whatever the location is going to come. I am going to return it is currently sunny at 75 degrees Fahrenheit, right? And let's say I have a calculator tool which calculate whatever the expression comes in. I am doing some calculation on it and I'm returning. And if I encounter error, I am also going to return this error, right? If in case I encounter error in calculation, I'll return this error as well. Now my agent will decide whether what this error was, how to debug this error and all that, right? And this is how I'm defining. Remember, I mentioned I need to pass the definition of the tool. I can pass this tool definition here also, right? Quoting in the string, and I can pass this information. I can pass what is the input argument, what is the output argument, right? Or I can pass it like this as well. I can build the tool. I'm converting these function into tools here, right? And I'm giving the name of my tool, which is my weather tool. The function attached to this tool is this, and this is my uh, description of this particular tool. Same for the calculator. This goes in, right? And this is the standard prompt that I'm using. Simply, you are a helpful assistant. That's it. This is the standard prompt that is available from OpenAI. Earlier, it was a create agent. Now we are trying to build a OpenAI agent, right? Uh, Internally, they are doing similar job, but it's just how we can configure. For OpenAI agent, you need to have your large language model wrapped in your OpenAI object, right? So I'm using Chat OpenAI model, which is 3.5 turbo. It is a quite like very old model now, right? And I'm configuring this, I'm creating this, and I'm just passing my LLM, my tools, and my prompt. The prompt is you are a helpful assistant. That's it. Nothing additional. You can write your prompt. The better you write your prompt, the better control you will have on your large language model, right? Someone says, does large language model still escape for this information from the web, even though it know the response to the query? Or on what basis does it hand the query to the agent or respond by? Okay, so this is a very good example of where our prompts come in. We are going to define the scope of my agent, what agent can do by itself, or what for which kind of scenario it needs to call the tool. It is passed through my instruction in the tool, how I pass my instruction. I can mention that you need to use if they for these kind of scenarios, try to use the tool as much as you can. If the query comes out of the scope, then you can say I do not know, or you can generate some information that is already available in your knowledge bank. We can explicitly mention, but this prompt is something that is going to completely control the flow of this agent, right? It is not that you just simply mention you are a helpful assistant and it will have all that. No, your prompt is your control over your agent. What to perform, which tool to call in what scenarios and all that. You need to define it very clearly. If this prompt is messed up, your agent might end up taking the decision which are not as per your expectations, right? Does this make sense? Okay. Yeah. So this is how we are building. And see, this is just one line of how you create your agent. It is this simple. We will see what is happening inside. Wait, hold your horses. If you want to understand what is happening inside, how this agent is being built, we'll come there. Just give me 5 more minutes, right? So this is how we are creating our agent, and we are creating this agent executor where I pass my agent. This agent has information about my large language model, all tools and everything, and I'm setting my verbose to true. What does this verbose equal to true does? Anybody? I just discussed just 2 minutes before.
Debug. It will debug. It will return all the results.
Okay.
All the results the LLM model returns.
Okay. Anybody else?
we can get the data in a console.
Yes, okay, that is also correct. Anybody else?
Will it help to debug in Langfuse more detail?
In Langfuse, it is independent whether you set a verbose true or false. It is independent of that because your Langfuse is already tracking your graph.
Will it give additional information, a little bit deep information by setting
Okay,
verbose
so it
specifically?
will give us the information about internal thoughts of your agent,
Okay,
what
okay.
your LLM is thinking, at what point what your LLM is doing. So if you see in here, initially for this question, I asked, what is the weather at New York? Also, what is 25 times 16? And what is the weather in Jaipur? So I have put in three questions in this particular scenario for which it needs to alternatively call different tools, right? For first, it needs to call weather, then it needs to have some calculations, and then it needs to again call a weather agent, right? Weather tool. So it will smartly handle, okay, first it took, okay, I need to call weather agent with this information, New York. I got the answer. Then it said, okay, I need this calculator with this information, 25 times 16. Then it had this again call weather agent with the information called Jaipur, right? And this was the final output. It is currently sunny at Jaipur. This was the final response that was coming in. So the chain finished in here with this response. This is the response. This was the input to your agent. And this was the output. The weather is New York is currently sunny with this. The result for 25 times 16 is 400, and the weather for Jaipur is sunny at 75°F. So your tools can work independently, irrespective of what your agent is working. Your agent should know what your tool takes in the input, what your tool is going to do, so that this agent can efficiently call the tool, which tool to call at what point of time. Your agent has that understanding, right? This is what your agent is going to do, right? So till now, we just saw on a broader level that our agent is calling a tool, right? But we don't understand how exactly it is underneath handling that process. Uh, Not sure if it is relevant to this context, but how are the tool calling agent and the MCP related? Okay, we'll come up to that. MCP is really good when it comes to tool calling. Model context protocol. How many of you are listening this term for the first time? Model context protocol.
Listen first time.
Yeah, even I'm hearing first time MCP. Yeah, model context.
Yeah. So this MCP, model context protocol, is just a little step ahead of our tool calling. It is making, just like in our already existing protocols, right? There are HTTPS protocol or some other protocol where your client and server goes hand in hand. Whatever your server is expecting, your client knows. Whatever your client is expecting, your server knows, right? There is a handshake between these two. So whatever your tool is expecting, that it is supposed to be in a structured format. Your client knows it. Your client in this particular scenario would be your large language model. And whatever your server is expecting, like for a particular tool to call, whatever your server is expecting, it expect a input in a design format, right? So it is much more complex or much more straightforward. You can also say that how your tool is being called, what is the information that is required, how that common ground has to come up in between, right? Where your large language model and your tools can go hand in hand. So this model context protocol streamline these functionality where you run a server. This server will host different tools in place. The information of these tools will be available for my client. Client in this particular scenario would be my large language model, and it is going to use those tools as and when required, right? So we can say MCP is a sophisticated form of tool calling agent. I won't say even sophisticated, but much more streamlined. Internally, this is what we are doing. There also we are doing some tool calling. It smartly calls those tools. But when I say streamline, what the tool is expecting in the input, the formatting or the structure of those scenarios, my agent understands how that tool needs to be called. There is this protocol in between that is taking place. So whenever I am building a tool, I am following a certain protocol, right? There is a certain format when which I am designing my tools, and whenever my agent is calling a tool, it is calling in a particular format. Let's say if you have a tool which is following a certain format, and your different tool is expecting an input in a different format. Your agent will get confused for like different kinds of input for different scenarios, right? So if you streamline everything, your large language model would be uh, faster or would be efficient in making the decision of what tool to call, how to get that input, and all that part, right? Does this make sense? Yeah, with much more standardization and protocol defined. That is correct. Yeah. We will be building a use case. I was planning, I'll be putting up the code in place that we'll be seeing how we can actually, and trust me, it is just the way we discuss right now, how we build those tools. It is exactly similarly simple of how you can build your MCP server, how you can run those tools, and how you can get this thing running, right? So we'll be taking this in our session further. But now, just tell me how many of you are interested in seeing what is happening internally of this tool calling. If you guys are interested, I'll pull up the notebook, else we can pass it to the next topic. Yeah, thanks. Thanks, Sumant. Are you guys interested in knowing what is happening internally when we are uh, doing this tool calling internally? Pass to next topic. Okay. Okay, in that case, I'll suggest you guys to have this. Um, there's something called React agent. React agent, as in reasoning and action. The full form goes as where you have some reasoning in place and you take some action based on whatever the reasoning is happening. And this is what I was referring to when we say what is the internals inside your tool, how the tool or how the agent is calling the tool, how it knows when to end, how it knows when to not end, how it takes those decisions, right? So whenever a question comes in, it start my agent, or here let's say my large language model is sitting, right? It will decide whether should I call a tool for this particular scenario or should I end. Here my prompt will decide if let's say you have tools like weather and calculator, right? And you ask a question which is, let's say, about something which is not at all related to weather and calculator. You ask some problem of physics, let's say, or you ask this model to translate something, right? So you control it through your agent or through your prompt, that whether to call a tool or not to call a tool, or what tool to call in which scenario. You can control it here in the initial scenarios. And let's say when your question comes in, your agent will decide, okay, now I need to break this problem and I need to call a tool, right? If the agent says I need to call a tool, then here my router will be connected. If it needs to call a tool, my router will say, okay, I need to use a tool. Which tool to call, everything, all this information my agent will pass. It will pass the name of the tool, right? It will pass argument, what arguments you want there in this particular scenario, and it will pass this information to my tool. Based on whatever the name it has passed, it will call that particular individual tool. It will pass this argument and it will process this information and it will return back the result back to my agent. Now my agent will decide whether the task that was assigned to me, is it completed or is it something left. Then if it says, okay, no, there was something else that was also, like in our previous scenario, we found the temperature or the weather of a particular location, and then we had a math problem, and then we again were inquiring about my weather, right? So what it will do, it will have all these plan of action in place. Okay, I need to call a temperature first. It will go and call the temperature first, return back, and then see if all the tasks are completed. If not, it will call another tool. Let's say in this case, it was maths tool. It will do some calculations. It will return back the answer, and then it will see if the task is done or is it still left. If it's still left, it will call another tool to get this action done, and it will come back here. Now my agent will decide whether all the actions has been completed or is it something that is left. If everything is completed, it will say, okay, now I can end. Now my router, which is my conditional, this is my conditional edge, it will decide which node to go for. It will say, okay, since all the task is done, my agent has said to end, then I will end it here, and it will end the whole process, right? This is how my internal of this particular agent things working. This is called my reasoning because I'm doing some reasoning in here. This router is doing some reasoning, and it is also acting depending upon whatever the reasoning was available at that point of time, right? The agent decides the end of the workflow or call a specific tool to achieve the goal. This is the main thing that is happening inside my React agent. Does this make sense? Yes, no?
Yes, yes, yeah.
Okay. Let me just show you how it looks like, how the conversation is happening inside the tool, right? Earlier in this particular scenario, we were looking it through the verbose, but let's just build everything ourselves. Let's just not import the tool just like that and build it ourselves so that we can see how things are flowing internally, right? It will just take 2 minutes because we already understand what is happening in here, right? So it will just take 2 minutes to go through the code. It will give you a better understanding, right? So in here, I am just building first of all my LLM instance. Here I am building my LLM instance. I have also built LLM OpenAI instance depending upon if your tool calling is not doing is not very great, maybe your agent is not that good, right? If your agent is not able to decide which tool to call at what point of time, that might be the scenario, right? So you need to also have like I have a good agent that you can work with, right? And then I have two of my tools, just like my previous one, get weather tool and my calculator tool. And this is where I'm building the React agent. But let's say building it from scratch. This is where we are doing to do this, building this graph. This is my state, agent state, where I have put in my messages, which is going to be a sequence of best messages, and I'm going to append this messages list. And this is also one way of defining my tool. I can pass it through a tool decorator, which is my LangChain core tool. I can pass it my definition in here of this particular tool. And based on this definition, my model will understand what the tool is doing. So this definition needs to be clear. And I can also bind my tool in this particular fashion. So rather than passing those tools in the agent prompt, I can pass it like this so that my model now understand what the tools it has at its disposal, right? And then I have something called tool node, right? Where the tool action is actually being taken. Whatever the tool is available, it will take the tool name and it will invoke that tool. Here I have the tool name, right? And I'm going to invoke that tool with the whatever the arguments that are available to me at let's say it was a calculator, then whatever the calculator arguments are available that were passed by my agent, or if it is a weather application or a weather tool that was called, whatever the things was done. This is happening in this particular line, and whatever are the output that I'm getting, I'm appending this in my outputs, and I'm passing these outputs back to my messages. So it's like I'm taking the state from my taking the whatever the message was there at that particular point of time. I take the last information, whether I need to call a tool, what tool to call, and if I need to call the tool, what is the name of the tool, what is the argument required. I process that information and append it back and send back to my state. This is where I am sending back it to my state. I'm updating my messages with the output information. Whether to call a tool or not to call a tool, this is where it is happening. This is my agent. May I know if all this code is human developed or LLM generated? This is augmented by LLM. This is debugged by me. And so it's like, it's not always that you can have a completely independent LLM generated code you can have, but if you are doing you are coding completely yourself, trust me, you are not using the AI. You should definitely, but do not just generate the code blindly. You need to understand what is happening. All these annotation and everything that you see in here, I have done it through the large language model. But what LLM have you used? I used the chat GPT models only. That's my, I would say, I generally use that model much more frequent compared to any other model. I have been using it for quite some time now. Okay. And okay, so this is where my agent is going to decide what tool to call, what tool not to call. You are a helpful assistant. Please respond to the user query to the best of your ability. And then I'm invoking my model. right? I'm passing in my message and I'm passing, I'm asking the model to respond based on whatever the question is, right? And this is where I am deciding should continue is going to be my router, the router that we discussed earlier. This is going to be my router, which will decide whether to end. If the last message is end, then I'm going to end. If it is not end, then I'm going to continue, right? If there is no tool call in the last message, I'm going to end this particular scenario, right? And then I'm building my graph, just like my line graph that I was doing. I'm adding these nodes. I'm setting the entry point. You can either start with a start import that you have done, or you can do this entry point, set entry point, and you can pass just one node in here, right? And then you can do you see these comments? It's good to have these comments. You can add these comments. These are already like LLM generated. Once you generate this code, also see if you can cross check whatever the at this proper documentation that is done. Is it correct or not correct? Just it's good to have till the time you build enough confidence on it, right? You build this agent, you connect with the a conditional function which is going to either return a continue or going to return a end. If it returns end, then you should end, or you need to call a tool, right? It will connect to tool, and this tool is going to connect back to the agent, because tool, whenever tool is called, it will process something and it should return back information to my agent, right? This is what is happening, and this is a simple React agent that we have in place. Where is the reasoning agent here? Probably I missed. So reasoning is happening in here, whether you should call a model or not call a model. This is where it is deciding based on the user question. Should you end the flow, or should you continue to call the tool? This is where this call model is taking care of that, right? So these are simple three important function in here: whether you call the agent, whether you continue or not continue, and how you execute your tool. These are simple three steps that are happening in here, and then you build your graph, and this is how you compile your graph. And this is a simple React agent flow that we just discussed. Internally, the tools, the agents that we saw earlier, they were internally doing a similar job, right? They were doing some reasoning, they were doing some conditional end kind of scenario, and they were ending up the results, right? And when you run this, you can have this kind of streaming. When you are going to stream this particular event, you can expect this kind of output. I'll share this notebook. I'll surely would want you guys to uh, do some hands-on on these notebooks. You can build some of your use cases as well. That would be interesting. We can also build some use cases together as well. Yeah. How can we pass the parameter like temperature, top P, top K, etc. for LLMs? Okay, so when you are defining your LLM object, in our case, we defined it here. See, we are passing a temperature, we are passing a model name, right? We set these parameters because these are the parameters when you are building your LLM instance, you set all these parameters. You do all this. Once you have this ready, then you get into and see. If I can show you, do you see this? Initially, when I invoked my human message, this was the human message that was in the input. Based on that, my AI said that I need to do some tool calling. I need to call with this argument city as Delhi, and the name is going to be get weather, which is a type of function. Then I need to call a expression with 3 cross 30, 3 cross 43, which is the argument I need to call calculate. And all this decision is taken by my agent. What tool to call, what is the argument to pass, and then tool was invoked. This was the get weather tool, and it gave this output. This was my calculator tool, and it gave this output 129. This was my get weather tool, and it gave me this output. And in total, this was my agent response at the end. So this is how the internal communication is happening between the tools and between the agent. The back and forth, the communication is happening, right? So this is the final output that you get. Is it making sense? Yeah. Okay.
Yes, yes.
Do we have any more questions in here? Yeah, I think we are already 5 minutes past our scheduled time. If you have any more questions, we can take it up now, or we can call it a day. But maybe put it in the chat how many of you are going to practice it, because if you do not practice, all this thing, all this discussion will just vanish from your head if you don't practice it. Okay, great. I'll be sharing all these notebooks to get you guys started with. You can build your use case over and above it. And what
Any
I would, yeah, please go ahead.
any link to any because this is the first time
Mhm.
I'm attending this type of sessions. I want to know any right document or any URL that talks about these LLMs.
Mhm.
Any
What
documentation,
exactly about LLMs you are referring to?
because think as a person where I'm very new to this one,
Mhm.
right? So I should
Mhm.
understand, because if I now I understand the your notebook, but some things, right, like you are creating an object of LLM, right,
Mhm.
instance of LLM, and then using that internal, that is very straightforward. But
Mhm.
what type to use based on the use cases to develop, right? Any URL, any link, any documentation that explains in simple terms, like LLMs, right? What are different LLMs are there, when to use those things? Any
We
very
did you attend our sessions, like earlier session? We have discussed how LLMs are built, how what is the temperature, like we show in one of our notebook right now. What is the temperature? What does temperature mean? What is top K that was mentioned in the chat? All this
Right, right,
we
right.
have.
These are the arguments. I understand these are the
Mm,
arguments. So,
mm,
but if you see here, right, this particular one,
mhm,
this is regular LLM, and you
mhm,
also showed me how to instantiate uh, AI type, right? Open AI type also. You're
mhm.
trying to instant two objects. You're
Yeah.
trying to model things with using both to see the accuracy of output, right?
Mhm,
So, like that, right? If you want to understand this chat grok, right? So,
mhm.
where we,
So
is any go ahead.
So these all are available open source on LangChain itself. If you just type LLM Grok, you will see a documentation of how you can get started with LLM Grok. What imports you need to do, what libraries you need to install before you get started, what are different parameters that you can play with. And one good thing is, I'm not sure if it will be available in here, but if you hover over it or if you click on it,
I think it might come in Studio. Visual Studio might be. It won't
yeah,
show
it,
it
it, it
here.
is. It comes in
Call up
Visual
the
Studio, but it gives you that official documentation with that what are
documentation.
different parameters that is expecting.
Right, 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 right,
You
right.
can explore around that. That will give you a good understanding.
Okay, okay, okay. Because we have so many different, like I can say, different type of different. Like we have Chat GPT coming, and we have Gemini AI. We have some other, right? So many different things are available in the market, right? So
Mhm.
now I think you might be more understanding chat, right? Chat GPT. So you are
Mhm.
using all those type of objects and trying to model your thing, right? Might be there might
Mhm.
be XYZ person who is more lean towards the Gemini AI and using those type of
Yeah, yeah,
similar
that can
methods, right?
happen.
It can happen, right? So
Yeah. Yeah, you can definitely. So, what happens is it's all about how friendly you get with different models. There are different model. Many of my team members have integrated the Copilot into their this VS Code and everything, and they use it quite very frequently. But I am not used to. So it's all about practice. I rather than asking model to generate the code, I try to first figure out the logic myself, and then I wherever I'm stuck. I just ask it to frame it or optimize the code that I have written in
oh,
in certain scenarios. Maybe not in all scenarios, but you integrate slowly. You move towards how you can optimize your efficiency or your work using those AI models. Not all work, but to start with, coding is a good example.
okay, okay.
Yeah. But I would definitely suggest uh, you start implementing. Trust me, whenever you will start, you will get stuck somewhere. You will end up with some of the error which somebody else might have also encountered. I myself would have also encountered, and then try to debug it. The more you debug, the more you learn. That's what my philosophy is.
Right. Because even in Collab, right, we have Gemini AI, right? So you
Mhm.
can ask
Yeah,
it
you
to
can use
explain the
that.
error.
Yes, you can
Yeah,
use Gemini.
use it, and it will try to fix your code, but it will give different solutions. But
Yeah, but depending upon if it works or not.
yeah.
Yeah, that is always a uh, I would say a challenge with AI. Not a problem, but a challenge. Yeah. Any more doubts? Okay, if we do not have any doubts, I think we can call it a day. We'll meet next week with new discussions, with new agenda, and I'll just request you all to practice.
Thanks, Ankit.
Yeah. Okay. Thanks, guys. Have a good one. Hope you enjoyed the learning.
Thank you.
Have a good one.
Yes.
Bye bye.
Thank you.
Yeah. Thank you.